Astronomy, the Science of the Heavenly Bodies by David Todd. Tycho, the Great Observer. Clear as Copernicus had made the demonstration of the truth of his new system, it nevertheless failed of immediate and universal acceptance. The Ptolemaic system was too strongly entrenched, and the motions of all the bodies in the sky were too well represented by it. Accurate observations were greatly needed, and the Landgrave William IV of Hesse built the Kassel Observatory, which made a new catalogue of stars and introduced the use of clocks to carry on the time as measured by the uniform motion of the celestial sphere. 3 years after the death of Copernicus, Tycho Brahe was born, and when he was 30, the King of Denmark built for him the famous observatory of Uraniborg, where the great astronomer passed nearly a quarter of a century in critically observing the positions of the stars and planets. Tycho was celebrated as a designer and constructor of new types of astronomical instruments, and he printed a large volume of these designs, which form the basis of many in use at the present day. Unfortunately for the genius of Tycho and the significance of his work, the invention of the telescope had not yet been made, so that his observations had not the modern degree of accuracy. Nevertheless, they were destined to play a most important part in the progress of astronomy. Tycho was sadly in error in his rejection of the Copernican system, although his reasons in his day seemed unanswerable. If the outer planets were displaced among the stars by the annual motion of the Earth round the Sun, he argued, then the fixed stars must be similarly displaced, unless indeed they be at such vast distances that their motions would be too slight to be visible. Of course, we know now that this is really true, and that no instruments that Tycho was able to build could possibly have detected the motions, the effect of which we now recognize in the case of the nearer fixed stars in their annual or parallactic orbits. The remarkably accurate instruments devised by Tycho Brahe and employed by him in improving the observations of the positions of the heavenly bodies were no doubt built after descriptions of astrolabes such as Hipparchus used, as described by Ptolemy. In his Astronomiae Instaurate Mechanica, we find illustrations and descriptions of many of them. One is a polar astrolabe, mounted somewhat as a modern equatorial telescope is, and the meridian circle is adjustable so that it can be used in any place, no matter what its latitude might be. There is a graduated equatorial ring at right angles to the polar axis, so that the astrolabe could be used for making observations outside the meridian as well as on it. This equatorial circle slides through grooves and is furnished with movable sights, and a plumb line from the zenith or highest point of the meridian circle makes it possible to give the necessary adjustment in the vertical. Screws for adjustment at the bottom are provided, just as in our modern instruments, and 2 observers were necessary, taking their sights simultaneously, unless, as in one type of the instrument, a clock or some sort of measure of time was employed. Another early type of instrument is called by Tycho the ecliptic astrolabe, Armulae zodiacalis, or the zodiacal rings. It resembles the equatorial astrolabe somewhat, but has a second ring inclined to the equatorial one at an angle equal to the obliquity of the ecliptic. In observing, the equatorial ring was revolved round till the ecliptic ring came into coincidence with the plane of the ecliptic in the sky. Then the observation of a star's longitude and latitude, as referred to the ecliptic plane, could be made, quite as well as that of right ascension and declination on the equatorial plane. But it was necessary to work quickly, as the adjustment on the ecliptic would soon disappear and have to be renewed. Tycho is often called the father of the science of astronomical observation because of the improvements in design and construction of the instruments he used. His largest instrument was a mural quadrant, a quarter circle of copper turning parallel to the north and south face of a wall, its axis turning on a bearing fixed in the wall. The radius of this quadrant was 9 feet, and it was graduated or divided so as to read the very small angle of 10 seconds of arc, an extraordinary degree of precision for his day. Tycho built also a very large alt-azimuth quadrant of 6 feet radius. Its operation was very much as if his mural quadrant could be swung round in azimuth. At several of the great observatories of the present day, as Greenwich and Washington, there are instruments of a similar type, but much more accurate, because the mechanical work in brass and steel is executed by tools that are essentially perfect. And besides this, the power of the telescope is superadded to give absolute direction, or pointing, on the object under observation. Excellent clocks are necessary for precise observation with such an instrument, but neither Tycho Brahe nor Hevelius was provided with such accessories. Hevelius did not avail himself of the telescope as an aid to precision of observation, claiming that pinhole sights gave him more accurate results. It was a dispute concerning this question that Halley was sent over from London to Danzig to arbitrate. There could be but one way to decide. The telescope with its added power magnifies any displacement of the instrument and thereby enables the observer to point his instrument more exactly. So he can detect smaller errors and differences of direction than he can without it. And what is of great importance in more modern astronomy, the telescope makes it possible to observe accurately the position of objects so faint that they are wholly invisible to the naked eye.